Okay, we're going to continue our discussion of solving systems of equations. Before we get started and going into the new lesson, quick review. Methods we've talked about so far was graphing. Solving system of equations by graphing, you're looking for the place where the two lines would intersect. Options of solutions would be an ordered pair, which would be the one point where the two lines would intersect. Maybe you could graph and get lines that are parallel. If lines are parallel, then there's no solution because there's no intersection. Or if you graph the system of equations, you could possibly graph the same line twice. And if that were to happen, you would have an infinite number of solutions because every point on the line would be a solution for the system. And when we're solving, whether it be graphing or substitution, or what we're talking about today, elimination, those are your three options you're going to get. Either no solution, an infinite number of solutions, or in most cases, you're going to get a point of intersection, which is simply going to be an ordered pair. All right, as we get into today's lessons, we're going to talk about solving a system of equations with elimination. And we're going to talk about the idea that we have to multiply in order to get the same number or same coefficient in front of one of our variables to make so that it will eliminate. As we take a look here, when you're solving a system of equations with elimination, it's easiest to do if both equations are in standard form. Remember from our days back with linear equations, we would talk about standard form being the form of ax plus by equaling c, where a, b, and c were all numbers, integers, non-fraction, non-decimal. And your variables x and y were on one side, and then the constant c was on the opposite side of the equal sign by itself. And as we look at the first problem here, yes, they are both in standard form, and we're looking for a variable that has the same number or same coefficient in front, and then also we want to have different signs. Well, with what we have right now, the x's have a 3 and a 1. The y's have a 2 and a 3, so unfortunately we don't have the same number in front. But if I look at the x's, I say, well, I could multiply this 1 times 3, and that would give me the same number in front. So we're going to go ahead and do that. So with multiplication, we multiply the entire equation through, and I'm going to multiply here by 3. And multiplying each term, well, 3 times negative x is going to give me negative 3x. And then we multiply the 3 times the 3y, giving me a plus 9y. And continuing to multiply that through on the other side of the equal sign, 3 times 8, I've got 24. Now remember, the goal in this is to try and get the same number in front. And as I look at my x term here and the x term there, I now have the same number. So I'm just going to rewrite that top equation here, just so I can see my terms lined up. So after we get that written up, we can see that yes, indeed, in front of the x terms, we have the same number, and we actually also have different signs. So when we had the same number and different signs, we talked about in the last lesson that we're just going to add the two equations together, and when we do that, that term, that variable x that has the same number for different sign, eliminates. They're gone. Gives me 0x. Combine my y's together, well, the 2y plus the 9y, I get 11y. And on the right side here, I combine the 9 and the 24, and we get 33. From there, we just simply continue to solve. To solve each of these, we divide by 11 here, divide by 11 on that side as well, and your y value ends up equaling 3. Well, this is the case where we're going to get a solution. It's going to be an ordered pair. I've got the y value. I'm going to take that y value, bring it over here, plug it into one of the equations. I'm just going to use this bottom one here because it's convenient more than anything. I bring the negative x down, I put the plus 3, and since I know that y is equal to 3, we are substituting in, and we're going to put that 3 in here for y. Equals 8 comes down, write the rest of the equation down as you see it. As I start solving, I need to simplify this, so I multiply the 3 times 3 here and get 9. It's equal to 8. To solve this, we subtract 9 on each side. Subtracting 9 here on this side as well. and I end up with negative x is equal to negative 1. Well, we don't want the negative in front. We've talked about this before. You can divide by negative 1, and dividing each side of your equal sign by negative 1 is just simply going to switch your signs. So when you divide by the negative 1, x is equal to a positive 1, and your final answer is the ordered pair of x is 1, and the y value is 3. So, taking a look here at our second example today, we're looking to do the same thing with elimination. We're trying to get so they will eliminate. The equations are in standard form, so it's set up to eliminate. I can look at my x's here and say, oh, I could multiply this top equation times 3. And if I multiply that times 3, it's going to give me the same number in front of my x. So let's go ahead and do that. We're going to multiply the top equation through by 3. Multiplying every term here by 3, so 3 times the 2x gives me 6x. 3 times the negative 3y is a negative 9y. And then that is equal to 6 times 3, which is 18. The second equation, I've already got the 6x there, so I'm just going to bring this over the negative 6x, the plus 9y, and that equals 9. When I put these together, I look at, yeah, the x's are going to eliminate, so in order to eliminate, we're going to add the two equations together because it's already set up with the same number in different signs. And they eliminate, give me 0x. I look at the y's and the negative 9y and positive 9y, they eliminate too. So really on the left side of the equal sign, what I'm left with over here is just simply 0. All terms are gone. On the other side of the equal sign, I have the 18 and the 9, and I get 27. Much like when we talked about substitution, this is a situation where the variable's gone. This is a situation where either you've got an infinite number of solutions or no solutions. And since this is a false statement, it's obvious that 0 is never going to be equal to 27. And that's simply telling us, since it's a false statement, this is the case where lines are parallel. And your answer for this is that there is no solution. Don't need to go any further with that. You can't find a value for variables. You are not going to find a place of intersection because, like I said, when you get that, you've got parallel lines and there's going to be a no solution. Now on this last one, you might want to pause the video. A little bit of a different catch to making this eliminate, but give it a pause. If you think you can do it on your own, give it a go. If not, you can continue on here with me and we'll take a look. So with this one, the catch with this is like with the x's, if I'm trying to multiply to get the same number in front, it's not necessarily easy to multiply 2 times anything to get 3. And likewise here, I can't really multiply 2 times anything to get 3. So I do, in this case, an old wrestling move, and I take and I do the old switcherooski. I switch around either the coefficients with the y's or the x's. And since the y's already have different signs, I'm going to deal with the y's. I'm going to multiply this top equation through by 2, basically just taking this coefficient, moving it up here to multiply. And then on the bottom equation, I'm going to multiply it through by 3 in an attempt to get my y's set up to eliminate. So I basically just brought this 3, moved it down there to multiply. I could have done the same thing with the x's, but I chose to do it with the y's since they already had different signs. Multiply this second equation through, I get 9x. 3 times 2y is going to give me a plus 6y, and that is equal to 18. In your other equation, as you are multiplying through here, 2 times the 2x gives me 4x. 2 times the negative 3y is a negative 6y. And I multiply the 2 times 4, and when I do that, I get 8. And exactly what I was wanting to have happen, I wanted my y's set up to eliminate. They do have the same number. The signs are already different. So in this case, we're just going to add the equations together. And when we add the x's, the 4x plus 9x is 13x. The y's, well, negative 6y and plus 6y, those eliminate, and it's equal to 26. Divide 13 here, divide 13 on this side as well, and your x value ends up equaling 2. Well, now that I have my x value of 2, much like we've done in previous problems here, we just simply find the equation up here. The second one's just convenient to work with, so I'm going to substitute this value of 2 in here for the x, and you've got 3 times 2. It's not looking the best. Let's take a look at that 2 and erase that. 3 times the x value of 2 plus 2y, and then I bring down my equals 6. Now to solve this, 3 times 2 is 6. Bring down the plus 2y equals 6. To solve for x, I need to subtract this 6 here to get rid of it. I subtract the 6 on this side over here as well. And I'm left with 2y equals 0. In a problem like this, people start seeing the 0 and they start thinking this is a no solution or infinite solutions, but that is actually incorrect because I still have a variable y I'm solving for. You just keep solving. Don't worry about it being a 0. To solve for y, you would just divide by 2. And we divide each side here by 2. And I end up with a y value of 0 divided by 2 ends up being 0. So in the end, final answer for this guy is an x value of 2, a y value of 0, and we have solved using elimination when we had to multiply the variables to get the same number in front.